Okay, for number 85 through numbers 85 through 93, we're going to use the leading coefficient test to give us the end behavior. And then for part B, we're going to factor, and those are the only two parts we're going to do this time. 85, x cubed is the leading term, so this one tells you, and it's a leading term because it's the one with the highest degree. So it's an odd power with a positive leading coefficient. So the end behaviors on this one are down to the left, up to the right. When you factor it, you can factor out an x, and then this is difference of squares. Oops, minus 3. And then so the zeros are 0 and plus or minus 3. Okay, for 86, x to the 4th is your leading term with an even degree and a positive leading coefficient. Then we know that both the left side and the right side go up. Okay, we could factor out an x squared, and then we have another difference of squares. So my zeros are 0 and then plus or minus 2. For 87, the leading term is x cubed. So with a positive leading coefficient and an odd degree, we have on the left side going down and on the right side going up. We can factor out an x squared, and so that leaves us x minus 3. So the zeros are 0 and 3. For 88, the leading term is 3x cubed. And again, just because that's the one with the highest degree. And this one has an odd degree with a positive leading coefficient. So this one is also down on the left and up on the right. I can factor out a 3x squared, and I get x minus 8. So my zeros are 0 and 8. Okay, for 89, the leading term is negative x to the 4th. So this one has an even degree with a negative leading coefficient. So this one has both the left and the right going down. Okay, I can factor out a negative. So notice the signs change because I'm factoring out a negative from each term, a negative 1. And I can treat this as a quadratic because this degree is twice as big as this one. And I have a trinomial. So, and then of course the last one is a constant. So factors of 20 that add up to negative 9 are negative 4 and negative 5. So this one factors x squared minus 4 and times x squared minus 5. So I have the difference of squares here, and I could even treat the second one, factor it with the same structure, the same pattern. It's just going to say x plus square root of 5, and then x minus square root of 5. That's one way you could approach it. So the zeros are plus or minus 2 and plus or minus radical 5. So another approach to x squared minus 5 is to just set it equal to 0 and solve. So that would give you this. And then you take the square root, and so you get x equals plus or minus 5. So either way, you get plus or minus 5. Okay, for part A, leading term is negative x to the 6th. So I have an even degree with a negative leading coefficient. So both ends, left and right, go down. I'm going to factor out a negative again, as I did on the previous one, so that's going to give me x to the 6th minus 7x cubed minus 8. Again, notice that this degree is twice as big as this one, and I've got 3 terms with the last one being a constant. So I could treat this like a quadratic, like I can use the same structure as a quadratic. So factors of -8 that add up to -7. Again, square root of 6 is x cubed. So that'd be -8 and then x cubed plus 1. Okay? Both of these are some difference of cubes. So here I have the difference of 2 cubes and here I have the sum of 2 cubes. So we're going to use the formula that I reviewed with you in class. So for the first one it'd be x minus 2 because the cube root of 8 is 2. The cube root of x cubed is x. And then the longer factor would be x squared plus 2x plus 4. And then for x cubed plus 1, cube root of x cubed is x. Cubed root of 1 is 1. That's the shorter factor, the binomial. The other one is x squared minus x plus 1 because 1 squared is 1. And then 1 times x is x. Okay? So the zeros are 2 and -1. Remember, this factor and this factor does not give you a real zero. Okay. For number 91, the leading term is x cubed. So with an odd degree and a positive leading coefficient, I know that the left side goes down and the right side goes up. I'm going to factor it because it's 4 terms and the first one is x cubed. I'm going to try just doing the little 2 by 2. So I put the terms in order. 3x squared -9x minus 27. And so I ask myself, what's the greatest common factor in this row? And the answer is x squared. And then something times x squared is x cubed. The answer is x. And then something times x squared is 3x squared. Well, that would be 3. And then something times x is -9x. So that would be -9. And you always check, is 3 times -9 -27? The answer is yes. So that means that it's factored correctly. So two factors are x plus 3 and x squared minus 9. Well, x squared minus 9 is difference of squares, right? So it's x plus 3 for the first one, and then x plus 3 times x minus 3 for the difference of squares right here. So this factor broke up into these two factors. So I've got 2 of them. So you can condense it and write it with an exponent, right? So the zeros are plus or minus 3. For 92, the leading term is x to the 5th. So the degree is odd and the leading coefficient is positive. So this is going to have a down-up end behavior. And so I'm going to factor out, since it's 4 terms, I'm going to try the 2 by 2 again. So I'm going to arrange the terms like I did on number 91. So x to the 5th in the first box, and then -4x cubed, and then 8x squared, and then -32. So what can you factor out of the first row? Would be x cubed. What can you, or something times x cubed is x to the 5th. That would be x squared. And then something times x cubed is -4x cubed. That would be -4. And then something times x squared is 8x squared. That would be 8. And then you always check, it's -4 times 8, -32. The answer is yes. So that means that this is factored x squared minus 4 times x cubed plus 8. So we factor it further. And so this is difference of squares, x plus 2, x minus 2. That's for this one right here. And then for the sum of cubes, we already had it in the previous problem, right? A similar one. So this would be x plus 2 times x squared minus 2x plus 4. Okay? And these two factors here are for the sum of 2 cubes. And remember, this one never gives us a real 0. So the only real zeros are from these three. So the 0 are plus or minus 2. Okay, for 93, the leading term is negative 1/4 t to the 4th. So right here the degree is even and the leading coefficient is negative. So this tells me that both the left and the right are going to go down. Okay, for the zeros, I'm going to factor out a negative 1/4 to keep a positive leading term inside the parentheses, or leading, yeah, I guess leading term. So I'm going to put that there. And when I divide by 1/4, remember when I'm dividing by 1/4, it's like I'm multiplying by the reciprocal, so I'm multiplying by 2. So since I'm dividing by negative 1/4, I'm going to be multiplying by negative 4. So this becomes minus 8t squared, because I'm multiplying the 2 by negative 4. And so now I'm going to multiply the negative 4 by negative 4. So that gives me 16. And if you distribute this negative 1/4 here, here, and here, you will verify that you get the original polynomial back. Okay? So all I did was divide negative 1/4 from each of these. This one, and this one. And when you divide by a negative 1/4, it's like you're multiplying by 4. So now I'm going to factor the trinomial that's left. And, oops, negative 1/4. And because the degree here is twice as big as this one, I can treat it like a quadratic. So factors of 16, so that's t squared minus 4. And t squared minus 4, so it's squared, right? So now inside I can factor further. So this is 1/4 t plus 2 t minus 2 squared. So my zeros, try to squeeze, let me see if I can move this over. The zeros are plus and minus 2. Okay, so for 114 through 120 we have to state true or false for each statement. So 114 says a polynomial of 6th degree can have 1 0. And yes, actually, if you just look at the one that's already on there, f of x2 equals x to the 6th, this one only has 1 0. So the answer to this is true. It could have one. I mean, it does exist. 115, x to the 5th, a 5th degree polynomial having no real zeros. Well, if it's a 5th power, like right here, then one side has to go, one end has to go up and the other one has to go down. It has to. So it could either go like this, or it could go like this, and it has, so it has to cross the x-axis at some point. It has to, so this would be false. So 116, it says that a polynomial with an even degree can have a range that's all reals. Well, if it's an even polynomial, it would go something like this, where both ends go up, or like this, where both ends go down. So it doesn't have a range that's all reals, because it has a, for example, this one right here has a minimum value, and this one right here has a maximum value. So the range cannot be all reals. So this would be false. And then for the 117, this is the leading term right here. And so with a odd degree and a negative leading coefficient, it's actually the, oh no, actually that's true. It would have those end behaviors, so this is true. 118, I'm looking at this polynomial for all the next three problems. It says it crosses at x equals 1. This is false, because it actually touches. Why? Because the degree is even. Okay. 119 says touches but doesn't cross the x-axis. So this would be false, because it does cross it at 0 and at -3, because their multiplicity is odd. And then 120, The degree of this polynomial is x to the 6th, so this is false.